Hey everyone, this is the first video of its kind. One of the students requested to make a video on the sample question paper. So this was one of the tests in one of the institution where the syllabus was double and triple integration along with its application. So this was for 20 marks and there were 8 questions for the academic year 2020-21. So what I will do is I will show you the question. After that I will give you some hints. I will throw some hints at you and then I will go ahead. What you do is you see the question, pause the video, think for the solution. If you get the solution, great. Unpause it and see what solution I am giving it to you and compare it. Okay. And after the question, make sure you write the answer in the comment section so that others can also verify the answer. Okay. So this is what my plan is. I hope you will enjoy these 8 questions. And if you don't understand any of the hints, you're most welcome to ask me in the comment section. So yeah, let us start with the first question. So now let us try to solve the first question. So here is the very simple question for the first one. This is for 2 marks. So you need to solve this triple integration. So this is the integrand rho cube cos phi sin phi d rho d phi d theta. So now since this is the order d rho d phi d theta, so here this is the limit for rho, this is the limit for phi, and this is the limit for theta. Okay. So now what is my rho? So rho is 0 to 2. So when I want to integrate this, I can easily integrate first rho, which is rho raised to 4 upon 4 integration 0 to 2. For cos phi sin phi, I can use sine double angle. So I know that sine 2 theta is 2 sin theta cos theta. So this will be sine of 2 phi upon 2. And this is d phi and d theta. Right? And now I think this is easily solvable. This is nothing but you have 2 raised to 4 upon 4, which is nothing but 4 itself. 4 by 2 integration of sine 2 phi is what? Minus of cos of 2 phi by 2, and integration is 0 to pi by 4, and for 1 d theta integration is theta 0 to 2 pi. Okay, so solve this and tell me what is the answer for the first question. So this is the first homework for you. You have to tell me the answer for the first question. Okay, cool. Now let's go for the second question. So the second question is, you have to find the volume enclosed by the cone. Okay, so what is the cone? So if this is my xyz plane, I have a cone z equal to root of x square plus y square. So this is my cone over here, the standard cone. Okay, so this is my z equal to square root of x square plus y square. Okay, and what else is given? Between the planes z equal to 1 and z equal to 2. So if I try to draw the planes, suppose this is my z equal to 1 plane, and suppose this is my let us take this, the topmost one. This is our z equal to 2 plane. So this is the region, in between region. Okay, now I want to find the volume. That's what they have said, and we have to use spherical coordinates. Okay, so for spherical coordinates, if I want to find the volume, triple integration, I should have the limits of theta, which is the theta which is same as the cylindrical coordinate theta, that means along the xy plane. This is my phi, which will lie from 0 to pi, and there is the rho. Since I want to find volume, function will be 1 into rho square sine phi d rho d phi d theta. Okay, now let us try to find the limits of rho. Now to find the limits of rho, what you do, you draw the lines from origin, right? So let me draw this one line for you. Now let me take a different color. So suppose this is the line I am drawing. So you can see from where the line is entering, you can see from this line z equal to 1 is entering the domain, and from z equal to 2 the line is leaving the domain. So whenever you see straight line, now here you can see z equal to 1, but what is my z? Z is nothing but rho cos phi. So rho cos phi is 1. So what is the rho? 1 upon cos phi, which is nothing but secant of phi. So at this line, z equal to 1 is equivalent to rho equal to sec phi. Similarly, what about z equal to 2? What is my z? Rho cos phi. So rho cos phi is 2. So rho is nothing but 2 sec phi. Right? So from here you can see that your rho starts from sec phi, it will go till 2 sec of phi. So that is the limits for rho. So keep this in mind. Whenever you have a vertical straight lines, whenever you have the straight lines, trigonometry will definitely come into the picture. Okay, cool. Now I want to find the limits of phi. For phi, I know that it is here in this case, it is in the first octant. It is in the first octant. So definitely the limits of phi will be 0 less equal phi less equal pi by 2 because we are in the first octant. Otherwise the range for phi is 0 to pi, but since we are in the first octant, so the limits for phi will be, it will be 0 to pi by 2. And what is theta? You simply project this in xy plane. And when you project this in the xy plane, you get nothing but a disk, or you get the annulus disk, I would say, for z equal to 1 and z equal to 2. And you can see that the region is in the all the 4 quadrants. Therefore the limits of theta will be 0 to 2 pi. And now I think it is easy to solve, right? For theta, know where theta comes in. So for theta, the integration will be 2 pi. Okay. Then here phi. Then for rho square, it will be rho cube by 3. Will be secant of phi to 2 secant of phi to sine phi. Phi. Okay. Now here you can take out 3 outside. So this will be 2 pi by 3 integration 8 sec cube phi to sine phi minus sec cube of phi into again sine phi, right? So this is nothing but 8 minus 1 is 7 sec cube. So this is 7 to the 14 pi by 3. I hope my calculations are correct. So when you do these calculations, what you will get? So okay, I think this will be the best time to stop. You will have 7 sec cube of phi into sine phi, which I think you can write is as sec square of phi into tan phi. And then you put tan phi is equal to some say theta, or no, tan phi equal to t, then you can easily solve this. So that's the hint for the second question. To solve this, if you get stuck, you can ask me in the comment section. Do not forget to post the answer for the second question. Okay, cool. Now let us go for the third question. What is the third question? The third question says you have a region D which is bounded by the lines y equal to 4x minus 2. So let me draw the line over here. My diagram would be nice. Whiteboard. So y equal to 4x minus 2. How do you draw the line? When my x is 0, my y is minus 2. And when my y is 0, my x is 1 by 2. So this is the line joining these points. Okay. Try to draw this. Okay, cool. This is my minus 2 over here. That is 1 by 2 over here. And another region is y equal to 2 root x. That means x equal to y square by 4. Now x equal to y square by 4 means it is something like this, horizontal parabola. This is what I have. Consider this bounded domain, the region. Now here, what is this? Y equal to 4x minus 2, y is equal to 2 root x. Now what they have said, you have to set up the double integration. That means you have to find the limits for x and y. What is the order? Dx dy. So to find the limits of x, the first thing is you do is you draw the line parallel to x-axis. You see at which point the line is entering the domain and where it is leaving the domain. Okay, so it is entering from this parabola and it is leaving from the line. Okay, so therefore the limits of x will be, what will be your x? So from here you can see your x is nothing but y plus 2 by 4 less equal x less equal is leaving from the parabola. What is parabola? Y square by 4. and the outer limit will be y. So what will be the limits of y? Now we project everything on y axis. So you look at this point and you look at this point. So your limits of y will be this. So if you project this over here, so you find what is this point, you find what is this point, and yeah, this will be the limits for y. How do you do this? When you equate this, you have 2 root x equal to 4x minus 2. So if you square, you have 4x equal to 4x minus 2 the whole square. Get a quadratic equation, you will get the value of x. Once you have the value of x, you put it over here, you get the y coordinates. And that is what the limits of y is from lower to upper. Okay. So the third homework is you will tell me what are the limits of y, and the first part. The second part is you will tell me what is the answer. So pause the video and make sure you solve this question. Cool. Now let us go for the third one. What you are supposed to do here, in this case, you need to reverse the order of integration. So whenever you want to reverse the order of integration, the first thing you do is you first sketch the region. So here in the xy plane, this is the limits of y. Y is from x square to 2. So y equal to x square, we know that it's a parabola, and y equal to 2 is nothing but this line, right? Y equal to 2, y equal to x square. So this is the region we have. X is going from minus square root of 2 to square root of 2. Okay, now to reverse the order, that means what? First, it will be 1 times dx dy. Now to find the limits of x, what do? You draw the line parallel to x axis. So it is entering from this side of the parabola, it is leaving from this side of the parabola. Okay, so y equal to x square means what? X equal to minus root y to plus root, because y equal to x square means x equal to plus minus root y. And when you project this on y axis, you get this segment. So y will go from 0 to 2, because this is y equal to 2 line. So y is going from 0 to 2. And now I think this is not difficult to solve. 2 root y dy, and you can solve this 2 0 to 2, 2 times integration 0 to 2 root y dy. Easily solved. So that's the fourth homework for you. Tell me what is the answer when you solve this problem. Okay, cool. So we are done with the fourth one. Let's go for the fifth question. Now what is given to you? I is an integration which is given to you, and you have to write I in terms of cylindrical coordinate, but here the coordinates are x, r and theta. So in the theory, what you have seen, you usually put x equal to r cos theta, you put y equal to r sin theta, and you keep z equal to z as it is. Okay, so what will be your dx dy dz? When you do this substitution, it is nothing but r dz dr d theta. That's the standard thing you do. Now in this case, you want x, you don't want z. Okay, so what you do is you keep your x as it is, you put your y is equal to r cos theta, your z equal to r sin theta. Okay, again by the concept of Jacobian, your dx dy dz will be nothing but r dx dr d theta. So that's the one has to be cautious over here. Okay, now because of this relation, what will be this integrand? This integrand will be nothing but r square, and this term will be nothing but r dx dr d theta. So what do I have is r square into r, so equal integration of r cube dx dr d theta. Now what about x? X is 0 to y, so x limits are 0 to y. What is y? R cos theta. Now in yz plane, what are the limits? These are the limits. Y is starting from 0. So in yz plane, y is starting from 0 and it is going till square root of 1 minus z square. So if you square, you get y square plus z square equal to 1, a circle. It is starting from 0, so I will only draw the semicircle. Okay, so this is what I have, and x is going from, sorry, z is going from -1 to 1. So I think this should be z and this should be y. Sorry, yeah. For y, when you draw the line parallel to y-axis, is entering from 0, is going till root 1 minus z square, and z is from -1 to 1. So from here, you know what is my r? The radial line. R is from 0 to 1 and theta is from 0 to pi, not 2 pi. Okay. Now when you try to solve this, integration of theta, integration of r for r cube for dx, you will have r cos theta dr d theta. Now you can easily solve. For cos theta, you will have sin theta is 0 to pi into, I think now I should not solve over here. You will tell me what is the answer for the fifth question. Okay, cool. Okay, let's go for the sixth question. Now you have to consider a sphere of radius rho less equal 1. Now this is, I think, very straightforward question, because you have to find the volume. Obviously rho is given, theta and everything, so you have to go by spherical coordinates. So triple integration, you have to find the volume. So 1 times rho square sin phi d rho d phi d theta. Correct. Now what is your rho? Rho is sphere of radius less equal a. So rho is from 0 to a. Theta limits are already given to you. So theta is outside, which is 0 to pi by 6. And it is given to you first octant. So first octant means what? Your phi is from 0 to pi by 2. So here I think this is very easy. For rho square you have rho cube by 3. So that will be a cube by 3. For sin phi you have minus cos phi 0 to pi by 2. And for theta you have 2 pi. So I have almost solved this question for you. Tell me the answer for the sixth question. Okay, just pause the video and tell me the answer. It hardly take 2-3 seconds. Okay, let's come to the second last question. You have to find the centroid. Okay, so what is x bar? It is given by mx upon m. And what is your y bar? It is given by my upon m. And what is your m? It is given by double integration over the region R 1 times dy dx or dx dy. Okay, so let me write dA. Your mx formula is double integration over R y dA, and your my is double integration R m, sorry, not m, x dA. Now let us try to sketch the figure. It is in the first quadrant and x plus y equal to 3. So this is nothing but a straight slant line over here, which is passing through 3 and 3. So this is the triangle. See, I have mentioned this in the lecture as well. Whenever there is a question on centroid or center of mass, always draw the figure and try to see the symmetry. In this case, it is symmetry along y equal to x line. Correct? Therefore, the centroid will lie on y equal to x line. So you only find your x bar. You have to find x bar. Your y bar will be same. Okay, because the figure is symmetric about y equal to x line. Okay, so that was one shortcut. Another thing, now the first thing is you want to find the mass, but when the function is 1, this is nothing but what? This part is nothing but area of R. What is area? It's a right angle triangle. So what is area? Half into base into height. So 3 3s are 9, nothing but 4.5. This is 4. What will be your mx? Double integration y dy dx. And this is, no need to find this. Okay, because once you have x bar, your y bar is same. So you only find mx, no need to find my. Okay, now what are the limits? That you can easily see, right? What are the limits of y? You draw the line parallel to y axis. So the limits of y are 0 less equal y less equal 3 minus x. And when you project, the limits of x are 0 to 3. And yeah, so I think I will not solve this part. The homework for you is You have to tell me what is the centroid, what is x bar and y bar equal. That's the homework for you. Do pause the video or you can solve orally. But my suggestion is make sure you solve it. It gives you confidence. That's all. Okay, and here is the last one. So what is the thing? You have a sphere. So you have to take the part which is inside the sphere and outside the cylinder. So if I try to draw this part, so this is the sphere. My drawing is not good. Please spare me with that. This is the sphere over here of radius 2, and you have a cylinder of radius 1. So you have the part which is outside the cylinder and which is inside the sphere. This region you have, right? Okay, cool. Now I want to solve by cylindrical coordinates. Okay, so I need to find the limits of z. I need to find the limits of r and theta. So for z, what do? You draw the line parallel to z axis. When I draw the line parallel to z axis, it is entering from bottom part of the sphere, is coming from the top part of the sphere. Okay, so what that will be? It will be square root of 4 minus x square minus y square. So minus of 4 minus r square 2 plus square root of 4 minus r square, because my x is r cos theta, my y is r sin theta, z is z under cylindrical, right? Now when you project this on xy plane, what do you get? When you project this outside, you have a sphere that will become a circle of radius 2. Inside you have a cylinder of radius 1. When you project, this is the region you get. What are the limits of r? They are the limits from r is from 1 to 2. And what are the limits of theta? They are from 0 to pi. And now we want to find the volume. So your volume is nothing but triple integration, limits of theta, limits of r, limits of z, r, dz, dr, dθ. Okay. So I think once you know the limit, it's not that difficult to solve. You have the limit, so now you simply solve this and tell me what the answer is. If you get stuck, you can ask me in the comment section. I will be more than happy to. So yeah, these are the hints, and these were 8 questions which were asked last year. So all the best for your exam.